So we've seen now how to use generator functions. And part of the advantage of generator functions was that you could delay some of the computations by using, for instance, the cubes from or the squares from. You only needed to compute a new square whenever you were going to the next step in the iteration. So we can push this idea and we can use even more simplifying syntax using what's called list generators. So let's define some high constant. So in this case, it would be 10 to the 7. And let's take a list of all squares up to 10 to the 7. And you see that computing this list took a little bit of time. So I'll redo it. You see that it takes a little bit of time. On the other hand here, I'll create what's called a generator, and you see that this is instantaneous. So it's exactly the same syntax, except that I've replaced the square brackets for the list with those round brackets, and you actually need them. You need them here. You can't just remove them. And this creates a square generator. So a generator for all the squares. So you could have also a generator for all the squares plus 1, and this is how you would define it. So you would use the previously defined generator, and then you would do x plus 1 for x in squared gen. So you could imagine that this is kind of like doing a yield of x plus 1 for x in squared gen. And this is actually what it's doing here. This list generator is a shortcut for a very simple type of function generator using a yield. And in this case, it would be yield x plus 1. Okay, so once you have this, then you can do other things with it. For instance, call the sum. And this sum here, it's important to understand, this sum here is computed by taking all the squares plus 1 for all the numbers between 0 and 10 to the 7 minus 1. But at no point has the whole list been created simultaneously in memory. So this really creates element per element and adds it again, because sum is very smart and it knows that whenever it gets a generator like this, it should set some temporary variable to 0 and progressively add more and more terms, one after the other. So it should always ask for the next term, one after the other. So the difference is here. If you want to do to use a full list, then you have to create a new list with plus 1, and then you have to sum. So here at this stage, everything was created at some point in memory. Probably sum is actually a bit more efficient once you're giving it a list, because it knows you are computing the sum over a list, so it can start splitting up things and compute subsums and then sums of subsums. It can do things like that it cannot do with generators. But for the generators, you didn't have to create the object in memory. So sometimes this is very important when you're handling large amounts of data. Okay, so let me give you another example. So this example here is really to illustrate something you have already seen. If I want to take the cubes, so I have here all the cubes of numbers up to 1,000, and I compute the sum. So once I've computed the sum and I print the sum here, and then I ask for the length of the list of cubes, I get 0 because all the cubes have already been spent. So I could do the same operations but the other way around, and you will see that in this case I first compute the list of cubes and its length, that's 1,000, and then the sum of cubes, but by this time the cubes generator was already spent, so I get 0. Okay, so the take-home message here is that you can use list comprehensions, which is what is here with the square brackets, but this forces to create a huge list in memory, and a slightly better way to do it, and much better way in some cases, is using those round brackets, which gives you generators. And the generators, the point is that you're only generating the new object as you need it. So this is different from creating all the objects simultaneously. There are some drawbacks. The fact that you generate that object once and then it's spent if you want, but that's okay in many situations. So for instance, if you were to look for all the occurrences of a word in a file, like you had to do with Project Gutenberg, you would be better off to really use the different lines as generators the different lines in the file using generators rather than a full list of all the lines in the file, because it would be much more nice to your memory. You would use less memory and your program would be faster that way. You would treat line by line, and that's all that's important.